I've got another example verifying trigonometric identities problem here. Remember, I want you to make the changes only on one side of the equation. It can be either the right or the left, but you're basically transforming that side of the equation to equal the other side. Usually a step at a time. If you have two things that are basically the same kind of concept, and it's pretty easy to see those in parallel, you can do that. So like here, for example, this is the same thing as 1 over secant of theta squared, right? 1 squared is 1, secant squared is secant squared, same thing. And I'm going to show that on this other one too, okay? So notice that's cosine squared, and we can replace that. And that's sine. And again, if you've got two very simple replacements, you can probably show both of those at the same time, okay? So I'm replacing that with the cosine, it's being squared. I'm replacing that with the sine, it's being squared. That's equal to 1. And of course, we know the Pythagorean identity that sine squared of theta plus cosine squared of theta is equal to 1. So you can replace that with a 1. It's equal to 1 on the other side. And again, we've shown that the left-hand side is equal to the right-hand side. All right, so there's another identity verified. We know that that original statement is a true statement. All right, let's try another one here. We want to verify that the tangent of x is the same thing as the cosine of x divided by the sine of x times the cotangent squared of x. Okay, now a couple of things here. I'm noticing that there's no addition or subtraction in here, so I don't have to worry about common denominators or anything like that. I can break up the numerators and denominators any way I want to, which is really nice. I'm noticing that I'm going to rewrite this, I think, as a sine over a cosine times 1 over cotangent. So I'm going to simplify the right-hand side to equal the left-hand side this time. So I'm going to write this as a cosine of x over a sine of x times the cotangent's in the bottom, so that would be a 1 over cotangent squared of x. So hopefully you can see here we get a cosine on top, we get the same thing on the bottom there. Those are equivalent statements. Okay, that's a cotangent of x. So tangent of x is equal to, it's a cotangent of x times a 1 over cotangent squared of x. Okay. And of course, that means that tangent of x, I could multiply these together. That's over 1, right? Would be a cotangent of x over a cotangent squared of x. So kind of interestingly here, you might notice I didn't convert the cotangent over to a tangent, but it was because I noticed that I could get a cotangent in the statement, and I thought, you know what, I'll probably get some cancellation. So anyway, at this point, I can divide a cotangent out of the top and the bottom. And anyway, we can kind of close this out here. So that means that tangent of x is going to be equal to divide cotangent out of the top and the bottom. That's a 1 over cotangent of x. And remember, cotangent is the reciprocal of tangent. So I can replace it with a tangent, and that shows me that tangent of x is equal to tangent of x. And I have showed that that identity is in fact a true identity, okay? We get the same thing on both sides. All right, final example, verifying trig identities. All right, this last one, I've got 1 plus tangent squared of theta over the cosecant squared of theta is equal to the tangent squared of theta. And this can be done lots of different ways, so if you do it a different way than I do, not necessarily wrong. Okay, I'm noticing that 1 plus tangent squared is the same thing as the secant squared of theta. So I'm thinking, I see a cosecant squared and a secant squared. It seems like they might kind of have something in common. So if I see something that I just notice that I know is an equivalent, I'll usually try that first. The other thing is, if you can get an addition or subtraction out, most of these are a lot easier if you don't have addition or subtraction, because you don't have to worry about numerators and common denominators and that kind of thing. So again, I'm going to take the more complicated left-hand side and try to simplify it down to equal the more simple right-hand side. All right, this is the same thing as secant of theta over cosecant of theta squared is equal to tangent squared of theta, okay? And at this point, basically, I could move the cosecant of theta to to the top of the fraction as its reciprocal sign. I could move the secant of theta to the bottom as the corresponding cosine, okay? Maybe I'm cutting a little bit more of a corner here than I should. You know, maybe I should really be writing this a little bit differently. Actually, you know what I could do here? I could do this one step at a time. I could do secant of theta, and that's the same thing as secant of theta times 1 over cosecant of theta, and that whole thing is being squared, okay? And this is equal to tangent squared of theta. I'm going to continue up here. And this is the same thing as 1 over cosine. This is the same thing as sine. So that's 1 over cosine of theta times sine of theta, okay? Whole thing's being squared. It's equal to the tangent squared of theta, all right? And then at this point, that's going to be the same thing as sine of theta over cosine of theta. Whole thing is being squared. It's equal to tangent squared of theta. And notice sine over cosine is equal to tangent of theta. It's being squared, and that's equal to tangent squared of theta there. Okay? So once again, we've shown that the right hand and the left hand sides are equal. Again, if you wanted to cut this down just a little bit, it's not really showing each step one at a time, but because there's no addition or subtraction here, notice the cosecant will move to the top as a sine, the secant will move to the bottom as a cosine. Okay, we ended up getting it over here. This really shows why you're allowed to do that. But again, if you want to cut a little bit of a corner there and basically flip-flop these and write it as a sine over a cosine, we'll cut things down just a little bit. But in general, you want to be going one step at a time and showing how each thing turns into each other thing, all right? So hopefully those examples of verifying trig expressions are helpful, but remember, I need to see each step. I should be able to tell as you go from one step to the next what you did to get from that step to the next, what you replaced or how you wrote it in a different form. And again, you should be writing an entire equation each time you do it until you get down to an equation in which both sides are equal. So again, hope that helped. If you do have any questions, you know where to find me.